Hello students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. So those who are watching the particular session, please mark your attendance here. Hi Arush, good evening, welcome to the session. So I hope you guys have revised the topics we have covered in the last class. We have seen about the new term, right? Hybridization of the carbon. So in this particular session, we are going to discuss the versatile nature of carbon along with a new term again, isomerism. So this is our learning objective here, the versatile nature of carbon, and explain the concept of isomerism. Hi Durgeshwar, good evening. Ready? So here is the first topic, versatile nature of carbon. So what do you mean by versatile nature? Any idea? What do you mean by the word versatile? Okay, this particular word has a particular meaning, which means that any of the substance that can form different compounds or different bonds, right? Any substance that can form the different bonds or different compounds. Okay, this is a particular meaning for the word versatile. So here we are discussing about the versatile nature of carbon. Yes, it is special, right? So in the case of carbon, carbon has a tendency to form more bonds or more compounds with other elements, right? Why the reason behind that? What will be the reason behind that? It's are noted here. The carbon always forms covalent bonds. So what do you mean by covalent bonds? Okay, we have already studied in the 9th class, I think, about the bonding, right? Bonding in terms of ionic bond and covalent bond. So in the case of covalent bond, there will be sharing of electrons happens, right? Sharing of electrons happens. So here, carbon, because of the valency of 4, they can form the covalent bonds by sharing the 4 electrons in the valence shell, right? Is that clear what you mean by covalent bond? There will be two types of bond in the case of chemical bonding. One is ionic bond and the covalent bond. In the case of covalent bonds, these bonds are formed by the sharing of electrons. But in the case of ionic bond, there will be either gain of electrons or loss of electrons, right? Okay, fine. So in the case of carbon, their valency is 4. We have already discussed in the first class. So it is known as a tetravalent. So it has a tendency to form covalent bonds instead of ionic bonds. So this is the second reason. Then the self-combination property. Hi Ritik, good evening. The self-combination property, right? Carbon has a tendency to form bonds with other carbon atoms, right? So the property of self-combination of carbon atoms to form long chains is useful to us because it gives rise to an extremely large number of organic compounds or carbon compounds, right? So that is why carbon is showing the versatile nature, which means they can form more compounds or more different bonds because of these particular characters. Is that clear? Arush, let us see what are long chains. We will be discussing new terms here in the terms of isomerism, then we will see what you mean by long chains. Fine? Is it clear now? Why carbon is so special? These are the 3 reasons. Now, whenever we are discussing about the carbon, we are discussing about the organic compounds, right? Organic compounds. The compounds of carbon are generally known as organic compounds. So, if you are asking about the organic compounds, we can say that the main component in the organic compound is carbon, right? So, apart from the carbon, we can contain hydrogen. In the case of hydrocarbons, there will be hydrogen presence, and some other compounds will contain oxygen also. Let us see some examples here, right? So this is our first molecule, methane molecule. We will be discussing detail about the nomenclature as well as the classification of elements in detail in the next class also. So you will get an idea about how we can name a particular compound. So this is our first compound, CH4. What you're observing here, along with carbon, hydrogen is the other component here, right? Other element here. So carbon and hydrogen are known as the organic compound. Generally, if you are containing carbon compound, they are known as the organic compound. Carbon and hydrogen is known as the organic compound. For example, it is the hydrocarbons. What do you think? Carbon dioxide is organic or inorganic? See here, second example is ethane, right? C2H6, then ethene, ethyne, trichloromethane. Don't get confused with the names. We will be discussing detail in the nomenclature of carbon compounds. Ethanol, ethanol, ethanoic acid. So what you are observing here, along with carbon, hydrogen is also present and oxygen is also present, right? So these type of compounds are known as the organic compounds. And these special compounds are also known as hydrocarbons. Carbon and hydrogen, hydrocarbons. So, in particularly the carbon compounds or the organic compounds can be classified into these types, right? So, first classification is the hydrocarbons. If they are containing carbon and hydrogen as a component, they are known as hydrocarbons. For example, ethane, methane, these are the examples of hydrocarbons. It's not necessary for organic compound to be contain oxygen is not a necessary factor. We need carbon only. So just think about that. What about the carbon dioxide, whether it is an organic compound or inorganic compound? So in the case of haloalkanes means halogen compound, right? Fluorine, chlorine. These are the halogen compounds. If any of the compounds containing halogens group, fluorine, chlorine, bromine and so on. So these are known as the haloalkanes. Just go through the names here. The next class we will be discussing detail about the classification of hydrocarbons also. Then next one, alcohols. There will be some other case. There is also some functional group. So any of the compound which is having the functional group of OH or hydroxy group, they are known as the alcohols. Then about the aldehydes. I am just giving a brief idea about the introduction part about the organic compounds. So any of the compounds which contain CHO as a functional group, it is known as the aldehydes. If it is containing C double bond O as a functional group, it is known as the ketones. And if it is containing C double bond OH, COH group, they are known as the carboxylic acid. So these are the general classification of organic compounds, and the examples are also given here. Just go through it for a reference only. You will be discussing more detail in the higher classes also. There will be particular compounds which we are named as the functional groups. For example, if you are taking OH as one of the functional group, they have particular function. They will act as an alcohol there. If you are having OH is the one of the functional group there, they have a particular function. So they have the ability of the, characteristic of the alcohols. Similarly, there will be CHO, C double bond O, COOH and so on. Some other examples are also present for the functional groups. Just giving an introduction about the types of organic compounds. We will be discussing detail in this chapter also. In the grade 11 also, we will be discussing about the hydrocarbons. So this is just like a foundation or basics we are giving about the introduction part of the carbon compounds. Clear? Hi Parman, good evening. Okay, now let me directly move into the next topic, that is about the isomerism. I know that before that we need to get an idea about the nomenclature also, but I forgot to bring the note for the nomenclature. Just start about that. Just I will give a brief introduction about the isomerism. So do you have any idea about the isomerism? What do you mean by isomerism? Did you study in any of the lower classes about the isomerism? No, right? So, in the case of organic compounds or the compounds, we can write down some structural formula, right? Some structural formula. So here, I think I will need to start from the basics. Just giving a brief introduction about the isomerism. It is a phenomenon in which any of the two compounds, two or more compounds having the same molecular formula. I hope you must have idea about the molecular formula, right? For example, let us see in the detail about the isomerism. So any of the compounds which is having the same molecular formula, but they have the structural differences. They have the structural differences. Such type of isomerism is known as a structural isomerism. So in general, we can say that isomerism is a phenomenon in which any of the compounds which is having the difference in their structure or the spatial arrangement. This is a new term. We will be discussing later on in detail. So isomerism is a compounds which have same molecular formula but difference in their position or the structures also. So based on that, these isomers can be divided into two types: stereoisomerism and structural isomerism. Here in our, based on our syllabus, we need to focus more detail on the structural isomerism only. What do you mean by stereoisomerism? It is a type of isomerism, same molecular formula it is having, but the difference in their relative positioning of the atoms in space. I know that this is very difficult term for you whenever you are hearing about for the first time. So just for an introduction part or a basic, I am giving an idea about that. Clear? So we can focus about the structural isomerism here. In the case of structural isomerism, same molecular formula, right? Same molecular formula, but the difference in their structure. Let us see in detail. Yes. In the case of structural isomerism, we need to go through the three important type of isomerism. One is chain isomerism, other one is position isomerism, third one is functional group isomerism. So let us see one by one what do you mean by chain isomerism. What is the difference between chain, position and functional group isomerism? So what are you observing here in the case of chain isomerism? So here, two compounds are given, right? What are your observations? What is the difference between these two compounds? For example, I am asking to make a structure for this compound C4H10, right? C4H10. So what we have to do first? We need to draw 4 carbons. C4, right? 4 carbons. Four carbons, right? C4H10, 4 carbons. So what is remaining here? 10 hydrogens are present, right? 10 hydrogens are present. Here it is, we know that this C4H10, we need to, what is the valency of carbon? Okay, what is the valency of carbon? Pratik, that is why I am explaining here how to make the structural formula for a compound if you are giving the molecular formula. For example, if I am giving, one second, I will give the simple one. Is our question is to make the molecular formula for these compound C2, yes, C2H6. So 2 carbons are present, right? So I am writing 2 carbons. We already know carbon is having 4 valency. So we need to satisfy the valency for carbon as 4, right? So what you're observing here, these carbon and carbon forming one single bond. This one line stands for the one single bond. Then what about the other case? Carbon need to satisfy the other 3 valencies by hydrogen atom only, because it is contain only 6 hydrogen atoms. There is no any other atoms. So I am writing here. So this will be the structural formula for the C2H6 molecule. Is that clear? Which has valency 2? So in the case of this carbon, valency means how many bonds that they are forming in between, right? So here carbon is forming 1, 2, 3, 4 bonds with the other atoms. That will be the valency of that carbon. We already know that carbon is tetravalent atom. It has it need to form 4 bonds, so it must satisfy the valency of 4 only, right? That's why they are putting 3 hydrogen along with 1 CC bond here. Is that clear? Arush, I have already discussed in the last class. The first introduction part of the carbon itself is the carbon is a tetravalent compound. Its valency is 4, right? Electronic configuration. Carbon is having the electronic configuration of 2, 4, right? 2, 4 is the shell electronic configuration of carbon. So what is the number of electrons in the valence shell? It is 4, right? So it has a tendency to share 4 electrons. Clear? Arush, is that clear? Similarly, we can write down the structural formula for the C4H10 also. One carbon must satisfy 4 valencies. So here 1, 2, 3, 4. The remaining 3 will be satisfied with the hydrogen atom. So again hydrogen, 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 also hydrogen. So here 4 carbon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogen. So this is the first structural formula for the C4H10. This is known as a long chain compound. There is no any branches. It is a straight chain compound. Is that clear? Is the first picture is clear? Okay, now let us move to the second picture. So what is the difference here? What is the difference you are observing here? This is a long chain, right? This is a long chain, but here it is 3 carbon plus 1 carbon is above, which means it acts as a branch. We need to focus more new terms here. Right, CH3, CC, CH. So what you are observing here in this particular carbon, 1, 2, 3, 4. 4 valence is satisfied, right? Then again 1, 2, 3, 4. 4 valence is satisfied with 1 CH3 group also. Then here also 1, 2, 3, 4 valence is satisfied by the 3 hydrogen atoms here. So the difference is that here it is a straight chain compound, right? Here it is a straight chain compound. But here one of the CH3 group is coming as a branch. you will get a more idea about whenever we are discussing about the nomenclature and the identification or classification of elements only. So I will bring that, I will bring that idea in the next class. Tomorrow only I will give the idea about how to draw the structure and how to find out the name for the particular compound. Otherwise you will get complicated here. Okay, I hope it is clear for now. Carbon is so special here, right? So carbon has a tendency to form these branch compounds also. That's why. So here what you're observing? Again this is C4H10, right? C4H10. Then here it is again 1, 2, 3, 4 carbon along with 1, 2, 3, 4, 5, 6, 7 plus 3, 10 hydrogen. So what you're observing for these two compounds, both of them have the same molecular formula of C4H10, right? 4 carbons plus 10 hydrogen atoms. But the difference is that this is a straight chain compound and this is a branched chain compound. So this is the structural isomerism. Same molecular formula but difference in their structure. Is that clear? Is that clear? Just let me know. In the next slide we are going to higher compounds. So you may get confused here also. Just try by yourself whether you are getting different compounds like this. I will just explain first. So this is our C5H12 compound. C5H12 compound. When you are discussing about the nomenclature part, we will have an idea about whenever any of the compound having 5 carbon, it will be having the word root of pent. It will be having the word root of pent. Then if it is contain only single bonds, it will be contain alkane. Pentane will be the compound. No need of more confusions. We will be discussing the next class onwards about the nomenclature. Then you will get the correct idea about this. So here C5H12. I am just drawing a straight line structure here. But you are observing 1, 2, 3, 4, 5 carbon, right? 5 carbon. Each carbon should be satisfied by the 4 valences by taking hydrogen atoms. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So C5H12 means it is the straight chain compound that is known as a normal pentane. Okay, in order to get an idea about the isomerism, after completing the next session, tomorrow I will be completing the nomenclature of carbon compounds, then only watch this particular session. I will just give a brief idea about the nomenclature here also. If you are not getting idea about that, we will discuss later. We will discuss detail about the nomenclature in the next class. We need 1 hour session to complete the complete nomenclature. So I will just give an idea about this. So this is a normal pentane chain, which is a straight chain compound. So here the structure is little bit complicated. Okay, there is a mistake in this structure. Just leave about this structure. This is special case in the case of isomers only. In the case of isomers, we will be having different structures. First, we will go through the straight chain structure, then we can just change the branches also here. There is some mistakes in this structure, so we can just, I hope you understand about the isomers of these compound, right? This is known as a C4H10 compound. Is this clear? If this part is clear, just go through this part only. In the case of butane, it will be the isomerism, chain isomerism. Whenever we are discussing about the more length compounds, we will be get so confusion here. So just leave about this part here. You must have an idea about that in the case of C5H12. In the case of pentane, there will be 3 isomers present. One is the normal pentane, another one is the neopentane, and third one is the isopentane. This is the basic summary of the isomers, or I mean chain isomers of the compound. So in the case of C2H6, we have seen, right, C2H6. What is C2H6? So this is our C2H6, right, straight chain compound. So we cannot change the position of any of the branches. So it must contain only this compound only. It does not have any chain isomers. That's why it is given as nil here. And what about the case of C3H8? C3H8 means this is a propane compound. Again, if you are trying to draw the isomers of the C3H8, we cannot find any difference between the compound. Yes, we need to learn these structures. When you are completing about the basic part of the carbon compounds, I mean in the case of organic compounds, you will get the idea about the isomers. So just listen here. If you are getting the idea about this, go through that. Otherwise, watch the next session. I mean, the upcoming session I will discuss in detail about the basics of the organic compounds. So in the case of C4H10, we have seen there will be 2 number of chain isomers, right? One is a straight chain compound, and another one is the branched compound. Similarly, if you are going down, I mean for the higher compounds, C5H12 it will be having 3, C6H14 it will be having 5, then C7H16 it is having 9 and so on. So it will be more complicated. Just start with the C4H10 part, then you will get the idea about the chain isomers. Only the difference is that they have the same molecular formula but difference in the structure. I think in your examination point of view, you need to identify the isomers only for the lower alkanes, I think, from the C4H10 and C5H12. This higher case is very complicated, I think. In your examination point of view, in the board examination point of view, it is not necessary. Okay, now let me discuss about the position isomerism. So here also you will get confused here because you don't have an idea about the functional groups, right? So I will just give a brief idea about that. If you get it, accept, otherwise just leave it here. So here the isomers which differ in the position of functional group. The first slide I have discussed about the functional group, right? For example, if you are taking the OH group or this is known as a hydroxy group. This is one of the functional group. It has a function of alcohols. Right, so this is a hydroxy group. So if any of the compounds which is having the position of a functional group or the multiple bonds like double bond or triple bond or any substituents in the same carbon chain are called the position isomers. Just look at about these structures only. So what you are observing here in this first compound, this slide, right, Arush? For now, you can just focus about the structure of C4H10 only. When you are getting idea about the C4H10, just go through the higher alkanes. Maximum we can go to write down the chain isomers as these 2 compounds only. If we are using many higher alkanes, they will get confused in the structures. So you must have idea about that 9 isomers will be possible for the C7H16. Then C8H18 it will be 18. Then C9H20 it will be 35. Just for a reference. We need to write down the chain isomers, then only we can identify. I don't know any special formula is there for that. For higher alkenes it will be so complicated. So what we are observing here in the case of these two isomers, this is our functional group, right? OH group or hydroxy group. So here if I am giving the number for this carbon, so I will just start the numbering from here. We can start the numbering from here. So 1, 2, 3. Now your question will be asking about why we are starting from this side. Why not this side, right? So again in the nomenclature part we will be discussing about the functional group here. So here I am just giving an idea. In the case of hydroxy group, it must have the first position according to the IUPAC rule. So I am giving the first carbon number here. So what you are observing here, this OH group is present in the first carbon in this compound, right? First carbon in this compound. Similarly, if I am writing the numbering here, I will start from here only, right? 1, 2, 3. So what you are observing here, this OH group is present in the second carbon of this compound, right? Second carbon of this compound. So what you are getting the idea here, the position of functional group changes from these compounds. That is why it is known as a positional isomerism. Is that clear? Is that clear? Just let me know. So here the difference is that the position of OH changes. First it is here and second one it is the second position. So that is the thing that the OH group attached to different carbon atom in the chain. Different carbon atom in the chain, that is why it is known as the position isomers. Similarly, another examples are given here. Again this is also 4 carbon compound, right? So this is the another examples for the position isomers. So what you are observing here, again this OH is in the second carbon, this OH is in the first carbon. The difference in the position of OH in the carbon compound, that is known as the position isomers here. But it is having the same molecular formula of C4H9O. Then what about the second case? In the definition we have given that it must have the change in position of either functional group or the multiple bonds. Multiple bonds means it will be single bond, double bond or triple bond. So here in this case this is a triple bond, right? This is a triple bond. So what you are observing here, this triple bond is present in the case of third carbon, right? Third carbon, and in the case of here it is in the first carbon. So here also we can say that the position of triple bond is different here. So again it is a position isomerism. Okay, we need to draw the structures only. There is no any particular rule for that. Okay, once you are getting an idea about the IUPAC nomenclature, then only you can write down the structure of this compound. It's my mistake. I have given the isomerism part first before giving the nomenclature. Definitely in the next class I will be discussing about the nomenclature. Third case, I am just going fast here. Third case is the functional group isomerism. The compounds having the same molecular formula but different functional groups are known as the functional group isomers. For example, so here two compounds are given, right? Two compounds are given here. Yes, we need to learn this also. So two compounds are given here. So what you are observing here, an OH group is present, right? An OH group is present here. This is a functional group or a hydroxy group. So instead of OH group, there is one functional group known as the oxy group or ether group. So this is the one compound, ethyl alcohol, which was because of the presence of hydroxy group, it is known as the ethyl alcohol, and because of the presence of this oxygen, it is known as the ether. This compound is known as the ether. So this is a dimethyl ether. Don't get confused about the name here. Only the point you have to keep in mind that this is having the same molecular formula of C2H6O, but the difference is that they have two different functional groups. That is why these compounds are known as the functional group isomers. Okay, I hope you are understanding. Again, the another case is about the C3H6O compound only, C3H6O compound. So if you are asking about these three compounds, what you are observing here? So the marked ones are the functional groups here. In the case of first case, CHO means it is a aldehyde group. And in the case of acetone group, this is the C double bond or the ketone group. And here it is the double bond. So what you are observing here in these three compounds, if you are asking about the molecular formula, it is similar, C3H6O only. But the difference is that they have different functional groups. So these are known as the functional group isomers. Arush, no need to worry when you are getting idea about the basics of the nomenclature, how to write down the structural formula of the compound, you will get an exact idea of the isomerism. So before getting idea about the nomenclature only, we are getting confused here. Again, some of the examples are given here for the functional isomerism. C3. Now the molecular formula is C3H6O2. So what you are observing here, this is another functional group known as carboxylic acid, and here it is C double bond, COO. It is known as the ester group. This is ester. This is carboxylic acid. And this is again CHO, which is aldehyde. And here it is C double bond, or that is ketone. So difference in the functional groups, but have the same molecular formula of C3H6O2. Okay, for the first time it is very difficult to find out the structures of the compounds. Directly we are going to isomerism, it is very difficult. That's why I am saying I will be discussing the nomenclature or the structural part of the carbon compounds in the next class. So you must watch the next session, tomorrow, the same timing, 5 to 6. I will be discussing about the nomenclature part, then you will get the exact idea of this compound. It was my mistake to take the isomerism part first before going to the IUPAC nomenclature. So if I am starting about the nomenclature, it will take again 1 more hour to complete the session. So I know that it is very complicated. So we have just go through the isomerism part, which means that any of the compounds having the same molecular formula but difference in their structures or the positions. So depending upon the change in the structures or change in the position of the compounds, position of the functional groups or change in the functional groups, they can be divided into 3 structural isomerism. One is position isomerism, another one is chain isomerism, and third one is functional group isomerism. So you must have idea about that whenever we are discussing about the IUPAC nomenclature of compounds. First you need to get an idea about how to write down the structural formula of the compounds. Then only we can move to the isomerism part. Okay, I am just stopping here only. We can just practice some questions based on the isomerism part. Once I complete the nomenclature part, then I will discuss again about these isomerism here. So, please give me the answer for this question. Okay, this is the same question I have given in the first slide itself in the case of functional isomerism. So, ethanol and dimethyl ether, right? Ethanol and dimethyl ether. So these are the two compounds, ethanol. Ethanol means it is containing hydroxy compound as a functional group, and in the case of ether, it will be having oxygen as the functional group. So if you are asking about the molecular formula, it is having C2H6O, right? C2H6O. Both of them having the same molecular formula but difference in the functional groups. So what will be our answer? Option A, ethanol and dimethyl ether will be the example for the functional isomers. Okay, here is the next question. What type of isomerism is shown by 1 propanol and 2 propanol? I will just give an idea about this. If you are asking, any of the word root is prop, it means that it contains 3 carbon compound. So based on that, there will be table we need to memorize about how to predict the word root for a compound with whether it is containing number of carbons. So here prop means 3 carbon. So we can just write in the structure here 1, 2, 3 carbon, right? 3 carbon. So what you are observing here, this is propanol, which means this all stands for it is an alcohol group, which means the functional group is OH group. Okay. 3 carbon, other 4 valence, the remaining valences are satisfied with the hydrogen, and one of them will be the OH group. That is the structural formula of 1 propanol, which means that this OH group is present in the first carbon. That is why 1 propanol. So if I am asking you to write down the structure for the 2 propanol, what you are doing? You will just change the position of OH group into any of the second carbon, right? Any of the position in the second carbon. Then you will get the 2 propanol. So which means that this is the compound in which have the difference in their position of the functional group OH group. So here it is an example of position isomerism. Yes, structure is based on the IUPAC nomenclature. Definitely I will discuss it about in the next class, the tomorrow's class. Which of the following pairs are chain isomers? So just for a reference, I am giving the structure here. Once you are getting an idea about the IUPAC nomenclature, then only we can write the structural formula here. Now this chapter is not that much very difficult. If you have idea about the basics part only, we will get an exact idea here. So I will start from the basics tomorrow. No need to worry. So here pentane and 2-methyl butane are the example for the chain isomers. So I will just write down the structure here. This is a normal pentane. This is a 2-methyl butane. So what you are observing, one is a straight chain compound and another one is a branch compound. CH3 group is present here, right? The next question, which of the following statements about isomers is correct? Which of the following statements about isomers is correct? And the answer is incomplete here. Okay, this is the answer. Isomers have the same molecular formula but different structures. So answer is incomplete here. So according to all other options, we can say that option B is our correct answer. Yes, same molecular formula but different structures. So option B will be the correct answer. I hope you understand. Again, the repeated one, chain isomerism occurs when, or how we can define the chain isomerism. What will be the answer for this question? Yes, C only, right? So compounds have different carbon chain arrangements. One will be the straight chain compound and another one will be the branched one, depending upon the compound. So that is the exact definition for the chain isomerism. Then next question. The carbon forms covalent bonds primarily because. This is the first part we have discussed in this class about the versatile nature of carbon, right? So carbon forms covalent bonds primarily because. What will be the answer? Yes, sharing of electrons, or according to this question we can say that it cannot lose or gain 4 electrons easily, right? It cannot lose or gain 4 electrons easily, or it can share the electrons. That is the meaning of covalent bond. Is that clear? So answer according to the option given here. So option C will be the correct answer according to this question. Now let us quickly summarize the topic that we have discussed in this class. I know that you didn't get an idea about the isomerism part, so just leave it about that. We will be discussing the IUPAC nomenclature of compound in the next class. Then we can come back again to the isomerism part. Yes, so what we have discussed in this class, we have seen that the carbon is having the versatile nature, right? They can form the covalent bonds, they are tetravalent and they have the self-combination property also. That is why they are forming more organic compounds. Then we have discussed about the types of organic compounds, right? Carbon and hydrogen is having different compounds. So they are known as organic compounds. We have seen different types of organic compounds. Then we will be introducing a new term known as the isomerism. I know that you didn't get an idea about the isomerism part. So don't feel bad here or don't need to worry here about the isomerism part. This is very easy topic from the carbon and its compounds once you get the idea about the IUPAC nomenclature. So I will be coming back with the next class about the IUPAC nomenclature. We can start from the basics, then we can again come back to the isomerism part. Clear? Okay, that's all about from my side for today. So thank you so much all of you. See you in the next class. I mean tomorrow in the same time 5 to 6 I will be discussing about the IUPAC nomenclature of compounds. Then you will get an exact idea about how to write down the structure of the compounds. Whenever you are getting the molecular formula, we can easily write down the structure for the compounds. Then we can move back to the isomerism part again. Clear? So if you like the session, just hit the like button. Share this particular session to your friends also. And after completing the session, just go through the recorded session. Then you will get an idea about the isomerism part. Before coming to the next session, just go through the NCERT textbook, what you are going to discuss about the nomenclature part of the compound. So if you want to get the session PDF here. You need to join our Telegram channel, Infinity Learn 9 and 10 Telegram channel. You will get the session PDF after all the classes. So see you in the next class. Be ready with the nomenclature part of the carbon and compounds. Then it will be easy for you to understand. So thank you so much all of you. See you in the next class.